welcome everyone. This is our monthly MDBA Zoom speaker series, and we are delighted to have Fredrick Dunn back with us today. Fredrick Dunn is gonna lead us through a very kind of visual, informative presentation on bees and various aspects of beekeeping. So Fred, I'm going to turn it over to you so that we have plenty of time, and I'll let you say a few words of introduction and then begin your presentation.
So is that the green light I'm talking now?
Green light to you, sir.
Okay, well, thanks for having me back. If you were here last time, I just want to apologize. I coughed a little bit, ran away, Ian covered me. Good job. I'm glad that you came back. I'm going to share my screen. Let's see how this works. And, I have to move that, and I have to open this. And there it is, and I have to open that. And hopefully everybody can see that. Yes, okay. And you can hear me well.
Yes.
All right, so something you should know. I'm going to make the assumption that a lot of you may not even know anything about me. So I collect information about bees often just for information's sake. So there's a lot tonight that I will show you about bees. Some of it will just be old hat. I'm sure you're familiar with it. You've been around a while. I promise you one new thing tonight, one new bit of knowledge. So this, as I mentioned earlier to Ian, that this is happening on my kitchen table. I'm sure your kitchen tables look the same. You probably have a microscope set up. That's a hemocytometer. And of course, our subject is the honeybee. So we're going to move right into it. I don't know what your skill level is or your background, but we're talking about the Western honeybee, Apis mellifera. Sometimes people don't think about that name, but it means mellifera, honey transporter. So it is an insect that collects nectar and takes it from one area to the next. It's a social non-native insect. So I've been getting pushback recently about the fact that I promote a non-native, and I was even told it was invasive. It is not. We want it here. And I don't think that everyone should have honeybees in their yard. A lot of people do try to get more people on board to keep honeybees. My opinion is that if you're not absolutely fascinated and if you're not just full of desire to have bees under your care, it should not be motivated by money alone, although people certainly do make money from it. But they're adapted to pollinate. I'm going to show you about that. And we're just going to get right into it. Now, I know that you guys are suffering there under 60 some odd degree Fahrenheit weather. What if I told you this is like 3 weeks ago here? I'm in the northwestern part of the state of Pennsylvania, the northeastern part of the United States, of course, the Keystone State. No one gets northeast of us without passing through Pennsylvania. And we frequently win the snowfall records. So over 100 inches of snow, just to put it in perspective. The reason that this is interesting is I get a chance to test out a lot of different beekeeping equipment, hive configurations, and things like that. So we definitely challenge our bees with all of the full-blown weather situations that you can get. We get into the 90s in the summertime and well, of course, into the cold temperatures in the wintertime. And this year was particularly difficult because we had 6 months where the bees weren't flying. You can imagine that. So the configuration, I'm not going to spend probably a lot of time on it, but I do a lot of different hive configurations. This is my standard setup. Solid bottom board, Langstroth 10 frames, deep brood box, and then a medium that we put on that they store all their honey to get them through winter. That's what they're doing right now. We have dandelions that are just starting to open up. And so these two bottom boxes are just for the bees, nothing for me. The white things that you see above that, insulated inner covers, they're from Bee Smart Designs, and through the years, I've been keeping bees on this property since 2006. And I've made incremental changes to the way I manage and configure hives. And there are slatted racks on the bottom of these. Probably not a huge benefit to the bees themselves, but we use that. I am a treatment now, beekeeper, organic treatments, and I use the slatted rack to introduce oxalic acid vapor to deal with varroa destructor mites. So, and the top of the box is, of course, a feeder, and then insulated outer cover as well. So, this is the same day, same time. So we go back to the last one. Look at the landing boards and the entrances, melted away, open. they face south. This is a hive in the same apiary, same time and date, facing north. The landing boards get covered with ice and snow, as do the entrances. So I put this together, and we keep records year after year to see if it makes that much of a difference. It certainly does in getting them out to fly to do cleansing flights if we get a day in the wintertime where it hits the 30s and it's sunny. And this is my backyard. I'm sure it looks just like your backyards, with the Way to Be Academy building, top right there. My very first student, bottom left, he is 3 in that picture. We call him the supervisor. Today he's 9. And he tells me he's been a beekeeper since he was 2. And bottom right there is Way to Be Academy indoors. And this allows us to teach people about bees. We have 3 observation hives in there. If you are one of those people that just has to jump into your beehive and see what's going on every single day, as much as your bees might appreciate that in opposite land, they definitely don't mind if you have an observation hive and we just open the doors. So if you have people out and you're trying to teach them the biology of bees, it's great to have observation hives. And we have 3 so that something is going on in every hive, and they're at different stages of growth and development usually. So that's our teaching space. That's my grandson. He wanted me to make sure that you all saw him under a stormy sky in the apiary, even though he nabbed a bee suit that's oversized. Moving on. Now, this is my backyard, of course, and this shows some of the variable or variations in hive configurations. I want to, long-term, have my hives inside a building. I would like to have a hybrid greenhouse that's like a row barn, similar to what you keep horses in. And I want that facing south. I want half windows, and we just keep all the hives out of the wind and the rain and the weather. They tend to do better, and we can take care of them inside. But for now, they're outside. We have 2 yards right here within probably 150 feet of where I'm sitting right now. And then we have others that are several miles away north of us, which actually gets warmer weather, if that makes sense. I'm in a higher elevation here. So we have Apame hives, middle row left. We have the flow hive there, which I've been dealing with since they came out in 2015. Apame hives again in the middle, and those are the nucleus, and then of course the full 10 frame size, and then resource nucleus hives there on the right with the control wheels on the front. Resource hives, if you don't keep those already, I was slow to the game on that. And I like the wooden 5-frame deep nucleus hives, and of course you can super them up. I go 3 high on those, and I can just pull eggs, brood, maybe even take a queen if I need one, or if I need a placeholder, someplace to stash a queen when they're about to swarm, which happened today. I found swarm cells inside a hive that are about 2/3 done, and I found the queen, pulled that frame, pulled some brood, started a resource hive as an insurance policy in case they do not get their new virgin queens that will be coming out in the next 3 weeks here. If they don't get mated and come back, I can go to the resource hive, pull a queen, and return her. Bottom left is the ivory beehive that comes from Israel, from a kibbutz there. I ran into them at the North American Honeybee Expo down in Louisville, Kentucky. And I've been testing that out. Great for bees, terrible for the keeper. Just because it's like a barrel on its side. It has a 180-degree viewing window on it. When you pull it apart, all the frames have glued themselves to the interior of the viewing window, and it is a challenge to attend to. Second from the left on the bottom there is the Land's hive. Of course, a lot of people, it's kind of a club in itself these days, insulated with sheep's wool, and takes, of course, the Land's frames, and you'll end up having to have a couple of Land's hives if you want to be able to interchange your resources with one another. And that's probably my biggest gripe, is that you just don't have all the equipment you do with all the Langstroth-based systems. Second from the right, we have 3 hives in a row. I wish I could tell you that there's a definite hive configuration that just holds up to everything. Every storm, wind, we had an actual blizzard here this year, which is a lot of fun. And I would like to say that the most insulated hives did the best, and they did not. The Lyson hives did not do better than just the wooden 3/4 inch, standard pine or cedar Langstroth hives. The Apame hives, the plastic looking ones, have excellent configuration if you want to feed liquid, solid, and so utility wise, they're my favorite. But as far as survivability in extreme climates, none of these are superior as far as survivability through winter. It's really the stock of the bees, how well they're provisioned, what their mite loads are, and the genetics, the stock that we have here. That really gets them through winter. And once you have a solid colony of bees in a well-constructed box that you put them in, they seem to do well. The big difference is insulated inner covers. So that's all I'm going to say about those. The other thing is a lot of people don't mark their queens. I didn't either. Through the years, as I cycle back my own stock here, the cold weather bees tend to be darkening up. So we just have hybrids. I do go to the Weaver family, Daniel Weaver in Texas, if I need refreshing of my stock. And Carniolans, I also grab those. But if you've never marked your queens, I highly recommend that you try that. The reason I say it is we often think that our bees are not swarming, that they're not superseding the queens. But once I started marking them, I realized I'm losing queens right and left. So the question I had too is sometimes we're turning loose a queen or introducing one and she skips over the top of the hive. And it's every beekeeper's favorite thing to observe is that your queen flew away instead of going into the hive that you wanted her in. So do they survive? Can they make it? They're social insects. They definitely don't make it on their own. But what if I told you that foraging bees will join a queen that's orphaned out in the environment somewhere if she doesn't make it back to the hive? And the chances of having her come back to the hive are very low because you just got her through the mail. Next week, I have some Carniolans coming in because I have some photo and cinema work that I have to do. But this is what's happening in my stock through the years. They're getting dark like this. So it could be Carniolan. Saskatraz are dark, but mine are definitely mixed. So we're just going to talk about a little bit about the organization that goes inside the hive. The queen's not in charge. I'm sure we all know that by now. There are moments where she can make a decision and prevent things from happening the way you'd like them to go, but she's definitely not the decision maker. This is my favorite portrait of all time in beekeeping, and here's why. Only beekeepers know this face. This is the drone. If you don't know already, I've seen some very experienced beekeepers point out the drone and go, there goes the queen. And so getting acquainted with the different casts inside the hive is really interesting and important for obvious reasons. But the general public never sees a drone because they don't forage. They're not on the flowers. They're not at the nectar. They're not bothering your hummingbirds. So this one here, one of the reasons I like to show this is because we get a clear shot of the compound eyes of the drone. And I don't know if you're aware, but the anatomist, and if you're one of those people who needs absolutes, look at the lenses on the drone's compound eyes. First of all, they're not even the same size across the surface of the eye. They are hexagonal, just like their cells, but they number, if we combine both of the eyes, anywhere from 8,000 lenses to 10,000 lenses. So why is that? Well, because the drone can be produced by a worker bee, a laying worker. So those would be tiny and runty, and sometimes they come right out of a worker's cell. And then, of course, we get the full-blown, nice, heavy, fully developed and well-fed drones that come from the queens in a time when things are prime, like right now. Drones are what I look for if I need to jump into a hive to figure out if they're planning to swarm. And they're just starting that here in Pennsylvania. But that's a face that we are happy to see. In comparison, we're looking at the worker's eye. So compound eye, we know they have 5 eyes, including the ocella, but one of the interesting things about the honeybee is that the eyes have hairs sticking out between the lenses. Also, those hairs are different. So the ones coming out between the lenses are very slender. There's no branching. They're not plumose hairs. They're not instrumental in pollination. They just protect the eyes from getting dirty. So there are people that study hive or study animal hair, and I think that that's fantastic because there's a lot of funny stuff going on here. If you look at the top right there, we can see the hairs that are branched, that are plumose hairs, and the bees have a lot of uses for that we're going to go over here today. So some of the things I want you to understand about the drones, because that's the core of my story here today too, is they take 4 times the resources to develop and maintain when compared to a worker honeybee. So there again, we know about drone congregation areas, which is something that I've been recruited to help out with this year to document, video, and photograph drones in drone congregation areas and mating of queens on the wing and things like that. But this is another kind of drone congregation area on the left side here that we see at the end of the year. And that is that the drones kind of avoid the workers that otherwise would be feeding them. They stick all their heads together. They don't self-evict. So other than costing 4 times the food and resources to grow and develop, they also don't throw themselves out at the end of the year, even though the nurse bees stop feeding them. So the nurse bees here are actually culling them out. They're pushing them along and harassing them until they end up outside the hive. And the other thing is here on the right, it's a great opportunity to see a comparison. We have the drone facing to the probably 10 or 11 o'clock position, and then we have the worker facing at the 4 or 5 o'clock position, but we can see the size of their motor, the thorax, the size of the wings. So the drone has massive wings. These things are built for maximum performance and, of course, maximum consumption of resources. Their opportunity to loiter in a drone congregation area is very limited. Their chances of mating, of course, next to impossible, which is exactly the way we want it if we want strong genetics for our bees. I want the fastest flyers, highest flyers, most aware, most capable. And the queen, not the queen, but the workers don't seem to care about the size of the drone they feed. They care about its health and overall vigor. So they will ignore a full-size drone that has something wrong with it in favor of even a smaller one that came out of a worker cell or what we call a bullet cell when they're capped and heavily domed so they can squeeze in there. But size doesn't matter. Their health and vigor does when it comes to nutrition for the drones that are developing. So another thing I want to point out, because a lot of people write to me and want me to say all these great things that the drones can do, but what I've really focused on in this image is the tongue of the drone. If you look how tiny that is, I also want you to consider the size of its enormous head. The drone cannot even stick his head into a worker cell to get honey. They have to be fed. The other thing is regular honey, sugar syrup, something like that will not sustain a drone. They have to be fed a really rich protein enforced or reinforced diet from nurse bees. So they can get along. My grandson has collected them, tried to prove me wrong, and he feeds them different things, but they all die and end up in his matchbox by the end of the night. So they can't take care of themselves. Here's an example, a drone that probably was cut out earlier in the video. And so if you go at your landing boards early in the morning, I highly recommend all of you go out at sunrise and see what's on your landing boards. You will see if a colony is casting out developing pupa, for example, that might have mites or some issues with them. This particular drone is just tossed out because it's the end of the year. I want you to feel his pain because the very bees that cared for him, that nursed him, that provided him resources, one day decided not to, and then they forced him out in the cold, in the wet. What does the beekeeper do when you find a poor drone like this? Well, you take him to your kitchen table. And it's an opportunity to get a really close look at them because these are insects. And this is the abdomen of a drone. The abdomen of a drone is huge for reasons that we don't need to go into. He has to accommodate large equipment. And if you look at the sides here, you'll see little holes in these plates, and those are spiracles. So what got me really excited was that you could see them so clearly because he was coming in from the cold. And of course, the warm air caused condensation on him. His hair's matted down. And we could show his spiracles, which are connected, of course, to trachea and then tracheoles, just like little capillaries. So their abdomen expands and contracts diametrically and lengthwise while they're respirating. So you're looking at respiratory system and circulatory system all at once. And if you don't know already, most insects, including honeybees, do not breathe through their mouths. That's why they can stick their head completely in honey, and you'll see a bee with its head under the honey surface, still licking away at the honey, and that's because they're still respirating through their abdomen. So if you really suffocate an insect, you do it through the spiracles. So moving on, of course, everybody wants to see a squirrel. Who doesn't? But this is interesting because it's a good analogy. Your bees are trying to gain weight all summer long. They're preparing for winter. Look at this. These are blizzard conditions. The other thing is, what does a squirrel have all over it? Hairs. Why is that important? Well, hairs are important for a lot of reasons, but this squirrel, if I told you the truth, it would sound like fiction, has about 3 million hairs. What does that have to do with the honeybee? Well, the honeybee also has 3 million hairs on its body. We owe that to Associate Professor David Hugh of Georgia Tech, where they count hairs. So we're going to get a good look at this worker honeybee and some of the others, but I want you to see that thank goodness we have the equipment that gets us so close that we can even see the hairs along their mandibles. Hairs on their eyes, as we mentioned. They have a cuticle covering the entire surface of their body, their exoskeleton, which protects it. And so the hairs provide protection, and they have a lot of different functions. Some of them are collected to neurosensors, so that when a honeybee bites something with its mandibles, it knows exactly how much pressure it's putting on it. So, for example, pollination. We all know that. Most kids are learning that in school, thank goodness. Bees are pollinators. We have a lot of native pollinators as well, and there are even mammals that pollinate. But I like this one in particular because it shows the hind leg of this worker honeybee. She has pollen attached to her corbicula, and but this pollen, these anthers are purple, and I 99% guarantee that most of you looking at this don't know what this plant is. So I'll save you the suspension. It is Pinky Winky. It's a hydrangea. So these are cultivars. That's another polarizing point with a lot of beekeepers is some people want us to keep only native plants. And I put out plants that don't always make sense, but I decide what to put in my apiary based on what I find at the garden center. I listen and hear my way around the garden center to see what the bees are on. And that was the case with Pinky Winky here last fall, that it was humming with bees at a time when they were ignoring a lot of other things. So I went ahead and I got this. Who doesn't want to see purple pollen coming in to their bee hive? And then, of course, stacked with all the other pollens being stored. Now, this is fun because often we try to identify the pollen source by looking at the color of the pollen on the corbicula of your honeybee. But if we look at the pollen on the dandelion, it's pale yellow, but yet here it is on the corbicula of the honeybee, Cheeto orange. And the reason it gets that way is because your bees are, of course, amending it while they're in the field. So the processing of bee bread is happening while they're on the flower. Because the bee is, of course, sometimes carrying nectar or honey with her and using it to groom back, stick the pollen together, and it goes through the pollen press, which is part of the hind leg as well. And then it makes that little pack of pollen that's often colored a little different than the plant that it came from. These are some close-ups of the anatomical features of your worker honeybee. And the mandibles, again, the hairs on the edge of it, the hind legs, which are ready for pollen. The fun part for me is looking at this face, lower left, watching the way they flip their mandibles back. And when they swing them forward, it goes up against their mouth and performs a airtight, watertight seal. Now that used to be challenged. They used to think that bees could not sip like a straw, but through the magic of video and cinematography, we can demonstrate that they don't even have to move their tongues once they bring their mandible together and their proboscis together. And then, of course, the tongue can travel through that or not. And the other fun part is the contour of the mandibles perfectly matches the radius of the mandible when it comes together, or the proboscis. So here's the other thing, a honeybee doing what? Collecting water. So the fun thing about this is the thinner the fluid that they're collecting, the less their tongue moves. So we know that the bees dance for water more than any other resource in the hive. Now, the cool part of this is that I want you to appreciate the above average cinematography here. This is videoed at eye level to a honeybee on the pond side. So I'm not going to explain how I got that done, but the sun is coming through from the backside, so we can even see how translucent the abdomen is, and they can carry 60% of their body weight back there in what Dr. Tom Seeley refers to as water bottle bees. And then off she goes. But we got to see how the tongue worked. Here's another close-up, of course. Sometimes I like to drink through sand. So we do a lot of feeding with spirulina when we do not have honey supers on, or you will get blue-green honey. But spirulina can be added to your sugar syrup for those who sometimes have to beef up your bees. And we know that they go after algae and moss and things like that. And they also, these bees will come to the exact same drinking spot within about 5 or 6 inches over and over, and they're a specialist. So once they find a water source, that's a water bee, they never collect nectar. So the nectar collecting bees are separate for obvious reasons. If you have sugar, nectar, and that's being collected to come back and, of course, provide all of the carbohydrates that they need for the energy that they need, if you mix that with water, you would be, of course, diluting that valuable resource. So water bees are separate. They're not necessarily older than the others. It's just their calling. That's what they do. Now, in comparison, I want you to see, look what happens to the proboscis when they have a highly viscous or high sugar content like honey. Look at the tongue that's coming out. So they don't keep it closed up. Now they do have to move the tongue, and the tongue has hairs on it. So this is the glossa, and those hairs flex out and retract and increase its ability to get a lot of heavy sucrose. In this case, honey, though, in a very short amount of time because they're all about efficiency. And look at the mandibles. They're not even pressing against the proboscis anymore. It's just too much. And I just want you to pause and take in the fact that this is so well lit. It's in focus. The person that captured this is probably above that. Okay, we'll just move on. And then, so we want to see all these things that are happening. Lower right, there's the little bead of honey that's coming out so that it can groom it back and stick the pollen together. Center frame at the bottom, it is cleaning its antenna. The honeybee has to keep her antenna clean all the time. She has a special tool for doing that I'm going to show you in a minute. Also, all the way over to the left, they raise their abdomen and scrub their hind legs together. They have pollen brushes back there, pollen combs, whatever you want to call it. And you'll never see a bee with an uneven load coming in. And that's because they rub their legs together and they go through the pollen press and out onto the corbicula, and then they're ready to go. Now, just so that you can appreciate the trigger finger of the photos that were taken here, this is how it all comes together in the video at the top. So it's cleaning its antennae, it's raking back, its tongue is sticking out so it can get nectar, combing everything back onto the corbicula, and then it flew away. So it happens super fast. Look at these hairs. These are the branched hairs, plumose hairs. When a honeybee flies through the air, it generates a static charge. This is really interesting. That static charge has a lot of purposes. Some of the pollen that they encounter is not free and loose, so they may not need a static charge to get it to stick to their hairs. But what is also carrying a static charge is the flower. So when a bee visits the flower, it grounds the flower, there's a discharge, and this can be an indicator to other bees based on the static that they encounter residual to the plant, that it's already been visited recently by another honeybee. So the ability to meter static charge on a plant is really exciting. What does that do for you as a beekeeper? Nothing. It's just fun to know. It is fun to know. Now, the other thing, remember, they were cleaning their antennae. And if you're an anatomist and an entomologist, you get to name things. And so you can see the cuticle on this forearm. This is the tibia and the fibia of the honeybee. And if you look at that little iridescent gator skin looking part, they're constantly excreting small amounts of beeswax. And so it coats the exterior of their body to prevent them from dehydration. It also prevents them from being soaked and damaged. And of course, what is this radius that cleans the antenna called? The antenna cleaner. So, moving on. This is the other thing that I like to see. I like to see everything. Who am I kidding? I want to turn this down. Let me see. I hope that's not coming through too noisy for everybody. If you're teaching cinematography, and I know that's exciting to all of you, we talk about frame rates. So this is a fun physics thing for the bee. The way bees fly and flap their wings, there's a lot of discussion about the harmonics and the healing sounds of bees. You might be interested to know that they flap their wings at 226.8 plus or minus 12.8 cycles per second. Now, the reason that's exciting is if this bee were not carrying nectar and not carrying pollen, it's a light-loaded bee. So you would think then that the frequency of the wing beat would be slower, but it's not. The only thing that changes is the range of motion. So when they're light loaded, the motion is just a little bit fore and aft, and it's actually a little figure 8 sweeping motion that they have. And then when they load themselves up, 30% of their body weight on their legs, 60% in their nectar crop. Then we've got 90% of their body weight. Now the range of motion increases, the frequency remains the same. And if you can match your camera frame rate, which didn't happen in this particular sequence, it looks like their wings are just standing still. So if you're teaching about frame rates, it's just a fun lesson, which I know you just want me to move on, so I will. All right, now we're looking inside the hive. Observation hive, remember. Now, if you're sitting and waiting for a queen to hatch from her cell, emerge, I'm sorry. This is one of my biggest flaws. I mix emerging and hatching. So I have to be tight on this. They emerge at the queen cell level. They swarm, of course, makes me happy. This shows the normal distribution of resources inside the hive. Honey at the top, mixed honey and bee bread, brood comb, and it looks like every single bee in this hive is about to head out. And but they're not. They're just all activated. Now, how they decide who goes, who stays, I don't know, because you'll find very young workers that are capable of flight out there, and you'll find the old tattered winged bees out there. You'll also find some drones that just join up because they see something going on. But I want you to go outside with me and see the queen departing. So if we look at this landing board, and yes, this building exists just for that single hive, and there's the queen on the landing board. If you can see my cursor, where is it? She is right there. Now, what I want you to understand is bees do exactly what we want them to do. The queen does not always. And I'm going to mess with these bees. Look at the light color of this queen. I could just let her fly, but I have to know things. So where do they go? Onto a tree. Onto a tree where? Eye level? No. 15, 16 feet up, exactly where we need them to be, unless we can mess with their pheromones and we can get a queen mandibular pheromone onto a lower branch, which happens over here on the right. I get the same swarm from that tree to come down onto this branch so I can make videos of it and manipulate them with something called temp queen. Now you can also do this with something like Swarm Commander. Pick a branch. It's early in the year here, but if you can start to get some pheromones going on a branch, you can help direct them. The queen goes where this cluster is. It looks like they would surround the queen and go where she is, which they can, but usually the queen moves down the branch to wherever the cluster is the largest, and she buries herself in there. So let's move on because I have things to do. This is my messing with bees for no particular reason. This is a carniolan that I ordered from Better Bee, which probably got it from Oliveris in California. Did I say that right? By the way, is it Oliveris? And so I ordered a couple of carniolans, and this is my queen on a stick. And I just put her out there at a time when colonies are swarming. I decided if I can get worker bees to collect on this queen cage, completely new to Pennsylvania, before sunset, if they'll take care of her, then I'm going to leave her out there. And they did. Within 5 minutes, I had foraging honeybees fly into the pheromone stream of this queen and come over and start attending to her. Now, the following morning, I missed the swarm. So what's happening here is, of course, some above average beekeeper put a queen on a stick just to play a game, and they had flown away. They were trying to take her to a new spot. So they found a place. This is their bivouac. They found a place. They all took off. They went to move into this location that they found. But because someone zip tied the queen to a stick, she could not go with them. So I waited and let them regather onto this queen on a stick in the cage. Now, here's the thing. Every honeybee that we're looking at here is a traitor. They have all departed from their resident colonies. They just happen to be flying around. They went to a pheromone stream that they thought was appealing, and they joined up. So just to save time, I would like to show you that this grows into a sizable, kind of a manufactured swarm of bees. So what I did is I'm going to collect the queen. I'm going to put her in one of those resource nuke hives, 5 frame deep. And I'm going to see if I can get these bees to stay with her because I left them out there for another overnight. So this is a get acquainted overnight. So this doesn't just happen in an afternoon. They've all spread her pheromone, but this is a cluster or a swarm of volunteers around a queen that came in the mail. So now let's go and take the queen, and I'm going to put her in this hive. Hope that's not too noisy. Let's kill the sound. Okay, so I did pull the cork out. There is a candy plug in there. I didn't want them just to take off and leave me high and dry. I also don't force the bees in there, so I'm not going to shake them on there. I'll use a butterfly net, which is my favorite thing to do. And this is muslin cloth. And the reason I do this when I'm collecting swarms is I want to see if there's a queen in there. I want to see who's moving into this hive. Now, I don't think there was a queen because when they took off, they would have just moved into that other cavity that they found somewhere, but they didn't have a queen with them, so they came back to the queen on a stick, who's now in this box, and they're finding her again. Pretty soon, they're going to open their Nasonov gland, and they're going to spread that, and they're going to pull all of the bees in, which they did. Perfect, which is just how everything happens for me in beekeeping. In my bee yard, everything is perfect every time. But the interesting thing here is these are foraging honeybees. They're at the end of their lives. I've got a queen that I put in this box that she's going to lay eggs, but biology tells us that these foragers would not be alive in 3 weeks. So what happens? They should expire, right? They should just dwindle, but they don't. And so this is a testament to how much drift is happening in your apiary. This colony was an experiment. This is late September. They should not survive, yet they made it through winter. So your bees are fortifying colonies just based on the pheromone emitted from that entrance. On their way home with groceries, they just go to someone else's house and they move in. So I don't know why I put that. Altruism is for females. Once again, the males don't do anything except they're reproductive resources for the hive. I think their name is Bryce. They wake up, they come out of their cell after being uncapped by the nurse bees, and they don't even clean their cell, they clean themselves. So they find the mirror, they are trapped by reflective surfaces. They're all about themselves. Okay. Some people will see this time of year. Lots of bearding on the front of your hive. This is not bearding, and I want you to know the difference. This is actually a bivouac. So if we look at all the other hives in this apiary, there are about 43 colonies spread out. No one else is bearding like this. So what's going on? How can I tell the difference between a bearding and a bivouac? Well, there are going to be some waggle dances on the surface of this because they're trying to find a site to finally move in. So what happened is the queen moved out. She just didn't fly away. She stayed on the front. They congregated around her. We have these high visors, which in high heat drops the landing board and front hive temperature about 15 degrees. So we look at waggle dances. Now, I don't know if you spend a lot of time looking at waggle dances on the surface of a swarm. This is in a bivouac location. So I did this for you because I want you to see the super slow-mo. This is 999.7 frames per second. Look at the left. This is a waggle dance. They are not just intonating her. She is bopping them in the face. This is more mosh pit than information sharing. Let's look at it over here on the right. See the waggle dancer? And she hits him in the face and her in the face. And you get it in the face and I smack your antenna. So it's interesting that it's much more physical than you ever thought. Why is that cool to know? It's just cool to know. Now, the other thing is grooming. We know that our bees are clean. I like to see a lot of grooming going on, but it was Dr. Tom Seeley who told me about in his new book that there's a dance that they do that solicits grooming inside the hive. So when a bee gets some dirt on it, they did a lot of testing on this by puffing dirt and then just puffing air on some bees. So they puff the air and the bee would startle and react, but when it found there was nothing on its hairs, it would not do this grooming solicitation dance, which is 4 cycles per second. However, if you puff them and did put particulates on the hairs, they could sense those particles and they did that dance. And then we have these, what basically look to me like career groomers. They hang out in the same area inside the hive. They seem to groom all the time. They're obsessive compulsive about it. They'll even pull off the mites. I like the ones that groom off the mites, but don't let them go until they've given them a few extra nips before they release them. I like them to bite their feet off, like the Purdue ankle biters. Um, that's just a really good picture of the lenses of a worker bee's eye. Okay, moving on. Another really good picture of the root beer colored translucence of the mandible. Okay. And then, oh, here's another behavior that's fun. Washboarding. Washboarding is really interesting to me because it only happens if you have a colony of bees that has a bunch of workers outside, and look at their forelimbs. Look how fast they're rubbing that surface. Their mandibles, as it turns out, are barely touching the surface. So the idea that they're collecting micronutrients is kind of low on the list of what this might be about. Some people think that because they're rubbing their feet, their pads of their feet, that they're actually pheromone identifying the landing board as well, which would help, in theory, the returning forager to know that it's at the right colony. The reason I don't think that's it is because this also happens up inside the hive, often way up underneath the inner cover, and I don't have upper entrances or upper vents, so that does not hold true. So this remains a very interesting behavior. You know the colony is strong. They have a lot of surplus workers. And if you got time to lean, you got time to clean. So I think that's what they're doing. And then honeybee intelligence. This is my favorite. We know that bees have big brains, that they can think, they can work things out. We also know that they're very into keeping the interior of your hive clean, which is why they evict themselves when they're sick. They get rid of things, or they seal it up with propolis if it's something they can't get rid of. This is an undertaker bee. So this is a testament to the intelligence of the bee and how quickly she wants to get a dead bee out of the hive. I want to point out to you that the entrance is bottom left. Where is she headed? Top right. Now she's going away from the entrance. This particular worker bee, undertaker specialist, wants all the other bees to know how hard she works every day, all day. Even other undertakers inside this particular hive try to arrest that dead bee from her and get it out the entrance, and she won't release. Now look, here's another undertaker bee. Where is she going? Down, left, out, doing her job. I don't know if you have these people where you work who just feel like once they have something to do, they want everyone to see them doing it before they finish. But intelligence, I don't know. She is spreading germs and dead bee material everywhere. Moving on. Okay. Now this is bees on a Ziploc baggie. I was not going to put Ziploc baggies inside a hive to deliver any kind of syrup or feed unless we proved it, tested it, show that it would or would not leak. So we were evaluating capacities of different bags, but that's not why the sequence is in this presentation. I want you to look at their feet. And when we see their feet up close, we know that they have 4 claws at the end of their foot. But when they get onto a smooth surface, like a window, your kitchen window preferred, or a Ziploc baggie like this one, notice that there is a little pad that is sticking down in between their claws. So the claws actually move out of the way so that pad can make contact, and that is called the aurolium. And so it's very interesting, and this is a very clean shot of that in action. So this is how they can climb up smooth surfaces, and for the aurolium to go out, of course. And there's a yellow jacket trying to feed unsuccessfully through the pinholes in this bag, I might add. So even that was interesting. But I just wanted you to see how their feet function. Moving on. I'm sorry. Does this bother anybody? This is a jumping spider. If you are a beekeeper, I'm sorry, you are going to encounter the bold jumping spider. I don't know if they have them in California. When I was in California, I saw a black widow in a drinking fountain. So I think this is much cuter. And jumping spiders don't build webs. You're going to see them in your beehives. Now, here's the thing about jumping spiders. They jump 50 times their body length. They go right out on the landing board. They help themselves to a bee, a live, healthy bee that was just returning. Why don't the guard bees go after the jumping spider? I don't know. Why can jumping spiders see the moon clearly? I don't know. You can't sneak up on a jumping spider. They have 8 eyes, they pinwheel, and they look straight at you. If you're a photographer trying to learn macro, jumping spiders are it because they hold their ground, they stay right there, they remember your face. Honeybees remember your face. Vespidae, wasps, and hornets remember your face. So, how you behave around them, you can actually win them over. And I'm sure most of you are sitting there right now looking at your screen thinking, I want to win over a jumping spider just the way Fred does. I want to see it. And see, so now in the sequence too, the bees, I'm sorry, we just won't keep showing that, but I want you to show you, this is my friend right here. This is Mildred, the jumper, who recognizes me because I did not introduce her to my hive tool in the way that a lot of beekeepers do. Why would you do that? You're just going to get another one. She's waving at me. Look at her arms. Hey, Fred, it's me. Glad to see ya. Anything you need me to do? So we have this ability as humans to assign emotion to things like that. And then you talk to an arachnologist who ruins your life by telling you that that's actually a threat display. That jumper thought it could take you. It was definitely scaring me away, which doesn't work. I choose to believe that that's my friend. These are things, if you haven't guessed, at your bee's face that can kill them. This is a skunk. I don't know how many skunks you have where you are, but here's the problem. My landing boards are well out of reach of skunks. But this is bearding on one of those high nectar flow times, and the skunk comes at night and knocks the bees down. And so we spent a lot of time looking at how high can a skunk really reach. I heard someone very early on in my honeybee education that a skunk will not lift its body off the ground at all and expose its soft underbody. Well, our skunks here in Pennsylvania are little gymnasts because they will reach right up to a 16 or 17-inch landing board. So my grandson and I, first of all, identify the ground underneath your hive here. It's definitely being worked by something. That is the same hive, and we elevated it now. That looks like 18 3/4 inches to the landing board. What are the odds that the same skunk that's been feeding here, look at the muddy footprints on the landing board and everything mashed underneath, they will harass your bees and eat your bees for hours at a time. Something worth getting under control. So Tippy Toes McGillicuddy comes back here the very next night and can reach that 18 3/4 inches to the landing board. Now, if this hive had been there to begin with, this skunk never would have gotten started doing that. The bees are handicapped here. They cannot see at night. The illumination coming off of this camera is a night light, so the bees can't register that. They can't fly out and defend themselves against the skunk. So I was thinking, what if we had motion activated white light that came on and lit up the skunk so the bees could light up the skunk? That would be a sweet video. So here it is. Another skunk comes through. The motion activated light comes on. The video camera gets it. This is going to be YouTube gold, which is important to me to get a few views going. But the skunk figured it out and knew it was exposed and would not scratch at the landing board. Very anticlimactic. So I don't have anything cool to show you here. Very disappointing. Let's talk about bee stings. This is fun. Most of us tell people that are learning about beekeeping, you get stung by a bee, you get that stinger out of your skin right away. Scrape it with your credit card. So of course you're going to unzip your bee suit, you're going to look around for that credit card, you're going to use your hive tool or your fingernail. Guess what? Like many other things, they've studied the bee sting and whether or not it's better to just grab it with your fingers. The reason you're told not to get it with your fingers and pull it out is because what? You'll squeeze the venom gland, right? And put more venom into the wound on its way out. Is that what you've been told? I was told that. Well, as it turns out, scraping it with a hive tool is the worst thing you should do because it leaves a portion of the stinger in 9 times out of 10. Scrape it off. There are 3 parts to that. There's lancets, so the 2 moving parts that pull it in, and there's a stylet that sticks down that is rigid that they travel on like rails, and they pull themselves in. They deliver 100% of the venom in 30 seconds. Now, I was told initially a minute, but the research has been done. So if you grab that and just pull it out, what really matters is get it fast. Unless you don't mind, you don't mind having the stinger. Now on the right there, the cool thing is my camera, I had a macro camera I was testing. It took 6 stings to the rubber protection on the housing of the camera. I had never seen that before. But one of the things that allowed me to do, of course, is look at these stingers up close. And if you can see my cursor, see this little yellow caterpillar looking piece here? There is a lot of hair on that. Why is that? So it can release information fast. That is where the alarm pheromone is released so that the other bees will come and sting where you were stung. So that's the first time with that stinger that I really saw that so pronounced, and I was really excited. And I know what you want to know next because I'm a mind reader. You want to see, how does it work? Well, this is a retired soldier that his wife volunteered his arm for me to have a bee sting it, and then we can see the venom being delivered. It's autonomous, it pumps away, has its own electrical system, very advanced. The bee can be dead, and yet her stinger continues to deliver its full potency. So, very interesting to me. Now, we're in the world of flowers. I'm sure most of you look at this right now and know that that's a milkweed. And look at the little amber paddles on there. If you're a fan of social media, you have probably seen the pictures of a honeybee with little paddles on her feet. And it's because of the 5G network and any number of other things that have caused these malformations of the feet. Or she's on a milkweed, and milkweeds have traps built into them. And while she's getting nectar, her feet slide into these little traps. And the plant parks a pollen pack on her foot. This is not beneficial to the honeybee at all. They cannot use this pollen. The interesting thing is, what happens this time of year, we just had Earth Day. People have posters with monarch butterflies and the wonderful symbiotic relationship they have with the milkweed. That is a false narrative. What is the milkweed getting from the butterfly? Nothing at all. Now, I'm not here to slam the monarch. I'm just saying that what you've been told is not the case. I am here to celebrate the true champion of the milkweed, which is the honeybee. Only the honeybee is getting her feet into those little traps, getting the pollen packs out. Look at this professional milkweed pollinator. She is taking a rest. Look at all the amber paddles on her feet. Every time she parks one of those little amber packets of pollen for the milkweed, she collects another one. It's like inescapable. And then they just keep adding to her feet. So if you look at my cursor here, this is where the actual foot of the bee ends. Everything else is another pollen pack that she has successfully passed from one floret to the next. Now, the cool thing too is when they come out, they are flat. Over the next 90 seconds, they turn 90 degrees. And this prevents that pollen pack from going back into the exact same flower that she got it from. And over 90 seconds, she will be then on another flower, and that guarantees that then she can only release it once it's made that 90-degree turn, which is a very interesting thing that happens while that little pollen pack yolk dries out as soon as it leaves the flower. Very interesting. So the thing is, it's the honeybee. Here it is. The foot is in the trap. You see the pollen's being delivered. And of course, it's gluing itself to her feet. So when you see landing boards, sometimes they'll have 4 or 5 on each foot and they're just flopping around, and it alarms people. She needs help getting these off of her feet. So she needs to do what? She needs to do that 4 cycle per second waggle dance down at the grooming station and get those groomers to take that off for her. But what I want you to see is this is what monarch butterflies think of the milkweed. It's just a place for their public displays of affection. They're making out. Sure, they're getting nectar from it. Are they doing any pollinating? No, the honeybees are. Look at the honeybees all over that. Which, by the way, for me, the honeybees there, this shows too high of a density of the honeybees. But the honeybees are the champions. Monarchs are just a bunch of show-offs. Let's look at the offspring of the monarch. What's it doing? Pollinating, helping the plant. What's the milkweed doing? The milkweed is doing its best to kill these caterpillars. It is putting out every toxin it can manufacture. Look at this caterpillar, it's so disrespectful. It is eating the flowers before they had a chance to be flowers. Once again, not against the monarchs, but don't fall for the symbiotic relationship that they're supposed to have. They're parasites to the milkweed. They need the milkweed to exist. The milkweed does not need the monarch, and the milkweed is doing its best to kill monarch offspring. So, I don't want you to watch this horror any longer. It's not like I would make you look at a big close-up of it. So moving on. I also live in agricultural areas here. We did a lot of testing with pollen last year. Pollen plants, we're looking at neonicotinoids and things like that. The results came back that my bees were not negatively impacted at all, even though they are gathering pollen from corn. And we sent those off. I think we collected them weekly last year and sent them off. And University of Vermont did the study. Now, other parts of the country are not doing well with these high concentrations of pesticides and stuff, systemic pesticides, but my bees are okay. We also sent plant samples, but I'm 50 feet from this cornfield where my apiary is. So things are changing. Just want to talk about plants a little bit. This is borage. Borage is interesting because it responds to the presence of the bee. Once a bee vibrates a borage plant and the nectaries start to produce nectar, every time it flies away, it will refortify the nectaries in 2 minutes for the next bee to show up. I also like to teach kids about this because they think plants are hairy. Plants don't have hair, even though we've talked about the bee's hair. We tell hairy looking plants to try combing it because they're trichomes. So good tie-in. So if you're trying to teach kids, they like that. All right, so borage, I like that. Now this is one of my favorite early spring plants. You may not have this where you are. These are skunk cabbage. Now what's interesting about the skunk cabbage plant, and I also want you to understand, whoever videoed this, clambered around in the wetlands on a cold day, these plants can be 20 degrees warmer than the surrounding temperature. So you get a degree that, it's 38 degrees, it's wintertime, you could have 58 degrees in this plant. Your honeybees will beeline to these little saunas while they get early pollen, and they get a lot of pollen from these plants. So they'll melt their way through snow and ice, and it's just a very fascinating plant. Most people don't know it at this stage. They look at the actual big cabbage-looking big leaves and everything later on, which are eaten by bears and a lot of other wildlife. But the honeybees getting in there are really interesting, and it's a very interesting plant. So just wanted to introduce you to that. And this, of course, is hyssop. A lot of people don't like it. I like it. Bees look good when they're posing on it. It's just a good plant. You should have it. Moving on. And freezing bees, something people worry about. You shouldn't. There's something called chill coma. And unless they hit these really cold death delivery temperatures, they can actually reanimate and fly away. This particular bee, covered in frost, 2 hours from now was warmed up and flying away on its own. Their chances of making it on their own are very low, but there are actual parameters established. So for example, 50 hours till death. If the longer survival is at 41 degrees Fahrenheit than at 32 or 50 Fahrenheit, that they have a longer life expectancy at 41 degrees Fahrenheit than at 50. That's interesting. But if the temperatures, if you have a recording system, if it doesn't drop below 28.4 degrees Fahrenheit, this bee is not dead. This is a worker on the landing board. What's the tell, by the way, that she's still alive? Look at her hind left foot and look at the aurolium making contact on the landing board of this lysin hive. She's going to snap out of it later, but they can't snap out of it if they've been at or below 28.4 Fahrenheit. Now, if you question this, I suggest you go out with the dinner plate and sweep all the dead bees you can find, dead bees, onto the plate, put them on your kitchen table, and let them warm up in the morning sun. And my grandson does this, and my wife often wonders why there are so many bees on the inside of the kitchen window, and it's because we are scientists. We have to know. Moving on. Don't forget the drone. Super sad. Teach children. If your child or any child comes up to you and has questions or shows a curiosity in what you're doing, share with them. He's overdoing it. Yeah, he thinks he's learning something with his fancy audio rig, but kids are really locked in to nature if we can give them an opportunity to learn from us. I really appreciate the grown-ups that took time with me when I was little. Most people couldn't stand to be around me because I talked too much. Hard to believe, I know, but I appreciate the biologist at the end of my street that sat down and showed me how to hold snakes. We do that with kids. And remember that bees are above average. And that's the end of my presentation. Thank you. So if there are any questions, I'm happy to stick around. I don't know how long I just ran. If I'm
Thank you very much, Fred. Yeah, so absolutely. If folks have questions, feel free to put them in the chat or go ahead and just ask away, and I'm
Can
sure.
I
Yep.
can I ask one question? I heard you mention the Weaver bee out of Texas. I read
Yeah.
a small article on it, and they were saying that it's mite resistant, and that
Yes.
his colonies don't have any mites.
I wouldn't say they don't have any mites, but they are definitely, I can put it this way, my first 10 years of beekeeping were treatment free and they used Weaver bees exclusively. And when I was inspected by the state several times, he found one mite in my apiary and he inspected every hive. And another inspection was a 2-mite inspection without treatment. So Daniel Weaver spent a lot of time in letting his bees die off and dealing with what we call survivor stock. It is hybridized. It has some buckfast genetics in it, and there's a lot going on there. And Daniel's future, of course, is in queen genetics. That's what he's working on even today. So yeah, that's true. But as far as not having any mites, the problem is their wintering yards, which are actually in North Dakota. He's been impacted by the proximity of other bee operations that have now challenged his, mite resistant stock is very delicate. Once we start to crossbreed with other stock that can't hold its own with mites, they water down pretty darn fast.
Thank you.
Yep.
There's a question in the chat. Fred says, any concern for my hive to get wet from water from sprinklers 2 times a day for a total of 10 minutes? So sprinklers hitting a hive twice a day for 10 minutes, is that an issue that you would think?
I'm going to get out of my, oops. Okay, so I can close that. I'm going to turn off screen. Oh, stop share. This will allow me. Oh, yeah, now I see all the faces. There are more than 3 people. Okay. So the sprinkler spraying the hive. I equate that to places that get rains regularly, like Florida, Southern Florida. It's going to rain every afternoon in some of these places, and the hives do just fine. I would pay very close attention to the orientation of the hive and the landing board. I would have my hive tipping towards the landing board, towards the entrance, so we're not filling a hive if you've got solid bottom boards. And the other thing is those hive visors do a terrific job. It's easy to make your own. And they deflect water that's falling down on it, spraying into it. I would just make sure that my hive was tilted and the entrance is probably small. I don't consider that a big issue. Nobody else? No questions? Okay.
Fred, you mentioned, I have a question for you actually. So you mentioned, obviously you deal with very different winters than we do, but I think, a lot of us here in California, we're also worried about, overwintering our colonies in terms of insulation or ventilation. And you did mention about the importance of you using insulated inner covers. So maybe what kind of insulated inner cover do you use, and why do you think an insulated inner cover is effective even on a 3/4 inch Langstroth sort of woodware hive, equal to the Apame hives that you have and things like that, when you mentioned that you had sort of equal survival of colonies over those harsh winters?
Yeah, well, of course, where we are, condensation is a big issue. And if you purchase a hive, probably even today, if you buy a kit, it has an inner cover, outer cover, and a little vent already built into your inner cover, and they expect you to vent it. So if you did not insulate your inner cover on the top of your hive, you do need a vent up there. And that's because when it's transitional, you're going to hit the dew point inside that inner cover and it's going to drip down on your bees and challenge them, if not in some cases be the final blow to your hive. So through the years, I don't do one thing to all of my hives at once. So if I do modifications and I want to see what the results are, I might pick a third of the colonies under my control, and then I might update that as I go and see that something's working really well. So the venting and non-venting resulted in, with the vented hives, I used to need 74 to 100 pounds of honey to get them through winter. When we did the insulated covers and did not vent, and I kind of got Dr. Tom Seeley is a very convincing fellow, and the whole idea that venting somehow was necessary. If we had the insulation, then we don't have condensation directly over the bees, and the condensation, which is very critical to your bee survival in winter, occurs now. The dew point is achieved inside the hive, on the side walls, lower third of your swarm, if your hive is sized right for them. So this is important no matter where you live. So the insulating that inner cover takes the heat off, literally. I've looked at the metal clad, the standard Langstroth covers. We hit about 135 degrees on those clad roofs, the telescoping cover. Without insulation between that and the inner space, your bees have an area that, again, either has to be managed intensively. So we did stress testing on beehives too to see what they could handle. And if they had plenty of fresh water, they of course vented like crazy. But when they're using their wings, they're wearing themselves out. So this is the other side of it. Like I said, that my hive configurations haven't necessarily resulted in, hey, this is the only one, or hey, this is the best. The health and vigor of the bees that occupy the space is number one. And then they seem to handle what we throw at them, but we have the ability to improve the cavity that they're in. So that insulation, even in hot climates, desert Southwest, for the cover, if nothing else, the cover benefits the bee's ability to control that climate. Now, the other part of that, for me with the not venting, I'm tying in a lot of different things at once here. One is that the higher CO2 levels that the lack of venting retains is negative for the Varroa destructor mite reproduction. So there's humidity in there that is higher than if you vent. Goes without saying, because the venting is passive. And even though the bees do plug that up with their bodies, trying to stop the venting if they can, or reduce it, it also benefits mite reproduction. So ventilation and more oxygenation up there increases mite reproduction, where otherwise it would drop to 1% of what it normally would be. So there are a lot of secondary benefits to doing that. And today they're calling it the condenser hive. We just called it not venting. So, but and so I tell people, if you insulate nothing else, just the inner cover, try it out. And Be Smart Designs did the one that I put in there, and they kind of are the only game in town really when it comes to a real durable insulated inner cover. And there are things I would definitely change about it, but I'm not a manufacturer. But that insulated inner cover is built with a vent side to it, so it's got polystyrene in it. And I would say that when people use polystyrene, make sure your bees can't be in contact with it. And the reason is they excavate it. And I have a video coming up that's going to be a complete mess, because the bees went up through and they chewed into the polystyrene, because the thinking is they consider that like a pulpy wooden surface that they're either trying to propolyze or excavate. And they excavated it. They're coming out a hole where there shouldn't even be one. So I also have copper tape that now I cover holes with. And the Be Smart Design, Cliff, the guy who designed those, doesn't want me to do that, but I want to do it because I want to keep my bees where I want them to be. So more insulation is good to a point. Beyond that, there's what they call a minimal return on your investment. Like, the bees are not necessarily going to show an improvement once you get past a certain point. And so the question comes up, why wouldn't you insulate your hives completely? So I tried the Lyson hives. I have BIQ hives that are not shown in my apiary right now because I'm testing them. And I don't like to deliver bad news to somebody who made a hive and wants everybody to buy it. Because where I live, when we get a warm up day, like it might hit 55 midwinter, and the hives that are heavily insulated all the way around do not react to that warm up in time. The ones that just have the standard 3/4 inch wooden hive configuration, get warmed up early, they sense the warm up, and they're out doing cleansing flights and returning to the hive. So there are some trade-offs to that. So then the other thing is, well, let's just make a horseshoe of insulation and have the south-facing front just not be insulated. I suppose you could do that too. So there's a lot of room, for improvement there.
Great. There are a couple questions in the chat. Someone asked, do you clean your flow hive flow frames over winter? So that flow hive that you've been working with, do you clean those frames over winter?
Okay. So I don't want to do a spoiler alert, but I have a huge wax melter this year. Now I've been doing the Flow Hive Super since Flow Hive, by the way, is an evil name for a lot of places. I've had people cross their arms and walk out the door just for mentioning it. So they have these frames, and that's the most expensive part of the hive. It has these leaves that move. They get propolis, they get beeswax in them, and there are areas that are not accessible to the bees. So when you get them out, and I've had them since 2015, and there have been some changes to the design, minimal changes. But what I do is put them in my wax melter. Now, I talked to the inventor of the Flow Hive, Cedar Anderson, his father, Stuart. He's an engineer, the father is. And I wanted to know how hot can I get these without damaging the plastic. So I wanted to push the limits. So I'm soaking the entire thing in 157 Fahrenheit water. And that melts all the wax and propolis out of it. And I also was trying to talk with some plastics engineers because I didn't understand how plastic can be restored or some of the brittleness removed just by soaking something in water. If it just, restores itself to an original form, I don't know what's going on there, but it has not damaged the frames. And so we use hot water to clean them. And that has been the best so far. And the problem is you need a big vat of hot water, and you run the risk of heating it too much and permanently deforming a $65 frame. But my point is, if you can't clean it up, you're going to have to take it out of circulation eventually. So that's what I'm doing this year.
Great, thank you.
Sure.
Thank
Oh, that was Brian's question?
Yep.
Did I answer it? Do you feel
Yeah.
satisfied?
Yeah, no,
Very
it's
good.
helpful.
Okay, and you can get that Man Lake melter for $1,700. It's a bargain at any price.
There's a couple other questions in the chat. Fred, there's one from Gigi asking, when you're feeding with the Ziploc bags on the inner cover, what size holes are you creating in those bags? And then she also asked, how are you blocking the upper vent on the Apame outer cover? That question about ventilation there.
Okay. So, well, I'll talk about my Ziploc baggies first. I use hat pins. They're the really long ones with the pearl at the end, which I'm sure everybody has. I just poke them in there. We don't want to fill, so if it's a 1 gallon capacity Ziploc baggie, we don't fill it past half a gallon. The other thing is when we're poking the holes, we come in 1.5 to 2 inches from the perimeter. So we don't poke the holes along the sides at all. So we can pin cushion up through the top. And that has worked. So, and the good news is because there's no trapped air in there, it does not express itself when there's a thermal change. Like we get 40 degrees at night and the next day it hits 78. It doesn't express or ooze out. So that has been kind of the formula. And we run the grid at a 1-inch grid, 2 inches in all the way around. And the fun part about doing that outside open feed when we were testing it was, as it showed in the video, the wasps that showed up could not feed and the bees could get their proboscis. That was the other thing we wanted to see. When the bees were feeding through this pinhole, they could get their tongue and their proboscis in there. Were they also then enlarging the holes, and would that then cause them to leak? And they weren't, and it didn't. So that was actually a really good side note too. So, and we were doing that. We even tested the highest wetting ability, you would say, in the syrup. So we were going 1-to-1 and lighter, 1 to 1.5. And that's 1.5 water. So we did not have leaks that way too. So it was good. Oh, and the other part was, how do we handle the venting through the Apame hive top? You can just, there's double bubble insulation and there's single bubble Reflectech style insulation. If it's a brand new feeder on there, your bees don't have time to plug those holes because they propolize all of those edges. Those are really nice feeders. I wish it would just close them up in design and rather than waiting for the bees to do it. But the single coat of double bubble, just lay it over the whole top so that when you put the top down, it even shows around the edges. And that's what it did last winter, and it arrested 100% of the air movement through the top and added to the R value.
Cool. Thanks, Fred.
You're welcome, Chi-Ji.
But Jason asked, what is your preferred method for controlling mites?
Okay. I like to punch there. Anyway, so my preferred method, and I've never had to go beyond oxalic acid vaporization. And I mentioned earlier that I was treatment free for 10 years, which meant that I was restoring my apiary every year, thinking that I could get this magical genetic thing built up. But other beekeepers moved in around me, and I could find my stock shifting overnight. And when oxalic acid was approved here in the United States, that's when I started playing with it. And when oxalic acid vaporization then was a delivery option, huge risk to people. So it's not something that you can hand to a bunch of kids. So at least we have dribble, for example, that works, seems to have very good efficacy with the dribble if it's delivered correctly. And so I had such good results with oxalic acid vapor, and because you could still be organic, and because it was also already present, if people were watching me years ago, I already speculated that they wouldn't have a problem with it because the pre-treatment levels in your honey and the post-treatment levels of oxalic acid in the honey were almost not measurable. So it wasn't getting into the honey. It was not detrimental to the bees as far as building up in comb and things like that. So oxalic acid vaporization partnered with, this is the caveat, the full spectrum of integrated pest management. So that's not the only thing I did. Genetics number one, and of course screen bottom boards, which were an early kind of method for, they had passive 15% varroa mite drop in open screen bottom boards down at University of Florida's Bee Lab. So I don't like the open screen bottom board. We close up the bottom board. We have a screen, but we have a removable tray underneath because I like to see the mites. And that's how we control them. So genetics. And this year, the drones, we mentioned before everybody kind of came in with Ian here that I was shocked. We were doing video this afternoon and we pulled some drones and we could see the drones through their cells by lighting them from the back, and we could see varroa mites moving around in there. And then we uncapped some, and the first cell we uncapped had 5 foundress mites in it. And we know that because the drone wasn't long enough in development for these to actually be maturing offspring from reproduction. So we had 5 mites that converged on a drone this time of year. So we know that the drones early spring are a fantastic way to remove and control reproducing mites. And so oxalic acid partnered with all of these other integrated pest management practices seems to work for me.
Fred,
Thank you
So,
very much.
so Fred, just to follow up with that, then, how often do you use your OA vapor? And are you doing 4 grams for 2 deep 10 frame box, or what do you end up doing? And are you doing it on just a regular basis, or are you testing for mites and only doing it based on your testing?
Okay, Rich, you're trying to set me up, man. Okay, because I have to say, follow the label. They did update the dosage, but they're also holding us to whatever label is on your current, your oxalic acid that you purchase, whatever's on the label is king. They did up it to 2 grams per box. A lot of people will say that's not enough. Keep in mind that I'm doing it when they are in dispersal phase, so what people call Fredrick mites. We have opportunities to really knock down our mites, 96% on average efficacy with a single treatment. So, and when does that happen? People are collecting swarms right now. It's frustrating to me because we have, I belong to a really big beekeeper organization, and our association people have, you know, like their beliefs and wait and see, count your mites after you hive a swarm. No, please get those mites while they're there and exposed, because as soon as the queen and they've occupied a space, you have the perfect opportunity to get them all now and verify the mite drop. A lot of people are not keen on killing their bees to count mites. I think I've shown in today's video that it is a mess in your apiary, that your bees are going into each other's hives all the time, and the numbers are much bigger than you would know. And when we get academics together and, you know, undergrads start marking bees and seeing how many are showing up in different hives, they're only marking so many. You're getting 20% of the hive are non-resident bees. They're just going wherever they want. So now a new thinking comes in. Oh, well, we should just treat the whole apiary. It takes a village kind of thing. And if they're spreading mites everywhere, but see, then the other discussion is, yeah, but those are the foragers, and the mites are on your nurse bees. And in spring, they're not even on the nurse bees, they're on the drones, because the drones are preferred more than nurse bees, thanks to Dr. Zachary Lamas making his parents go up to Vermont and count drone mites for weekend after weekend after weekend. So now we know they're actually after the drones, the physical drone, after it emerges from its cell. So we're counting nurse bees. So the counting is a problem, is I guess what I'm trying to get to. I don't want to make it a huge mess, but here's why I need to know. You can assess which of your colonies had the most mites by treating and seeing what the drop was in the hive. We want to know, I want to know which of my colonies are doing the best, because those are the ones I want to reproduce from. And then you'll meet someone from the Minnesota Bee Lab, Marla Spivak, who will say, that's a total waste of time. So, because we're backyard beekeepers, you know, we're small scale, and our genetics are disrupted with every swarm and with every mating flight that our bees take. So our chances of really controlling our genetic stock is so hard unless we live somewhere where we're isolated. I flood, you know, in my mind, I think I'm doing these great things. I'm sending out my drones everywhere like flying monkeys, and I want them to take over everybody's area. But, you know, one person shows up with a hive that they got packages from, and they produce drones. And in the fall, you know, here we get another swarm season, and the genetics are going nuts. And that's where I get these light colored queens that I know are not mine, and they just show up, and now my genetics are on their heads again. Okay, I took the long way around the barn, Rich, but when I treat the apiary, I now treat the apiary. I want to keep records of the ones that are doing great. Maybe that's not that beneficial, but if I'm doing oxalic acid vaporization, if it's a swarm, they get it on the 7th day, period. If it's an established colony, I do pay attention to what they're doing, mite drops and things like that, bottom boards. This is why I like the tray and the screen. When I start to see 15 mites dead in that tray over a 2-week period, they're on my treatment cycle. Others are, and I also examine the mites that are in the tray. We put those under the microscope. I want to see if they're chewed, if they're damaged. The long game is genetics, but we can't get everyone on board. That's the problem, I would say. Because people just, these bees are so good at honey, you know, I have to have these bees. And then there they are. So, and my backup, if I get a really loaded Varroa, you know, farm going in one of the hives, I don't want to euthanize the hive, because if we're doing Darwinian beekeeping, we have to euthanize those. But keep in mind, small backyard operation. Daniel Weaver, to his credit, destroyed 80% of his colonies over selecting for survivor line bees. We're talking deep 6 figures in losses to do that. I'm just a backyard guy, and I'm just trying to keep my bees alive, so I don't euthanize them. That's the one that's going to get the Formic Pro packs. And I will just let them have it. Some people are experimenting with Viroxan this year. I've got it because they gave it to me. But unless I can see a real reason to do an extended release oxalic acid, your brood's going to move out from under those little soaked cardboard pieces. And if I need it, I would use it. It seems to be pretty passive too. So I hope that answered your question.
I have a question on packaged bees. When you get them, how fast can you do the vapor?
Keep in mind that you're trying to establish them. So if I got a package of bees in, I would definitely install them in your nucleus hive or whatever you're starting them with, standard 8 or 10 frame brood box. And because we want to know some things about that package when it comes in. I personally want to know if the queen's viable. I want to know if she made the trip well. I don't want to do anything to them that could be construed as impacting the fertility of the queen. So I want to give them a full week once you set up the package. If they're drawing comb and things like that, this of course delays. Although I've seen them lay eggs and just started comb and they kind of drew it out as that pupa developed. But I like to wait until I see what kind of pattern I'm getting from the queen, what her fertility level is. And then once I know all those things, then I will treat if I think they're going to have mites. Was it a treatment question or did I just go off the rails? Was it?
No, that's fine. Thank you.
Okay, yeah.
Any other questions that are out there?
I have a question. I have a new queen in one of my hives and I marked her and I came back. I think she was newly emerged. I got her from swarm cells and, I came back 7 days later and she's still in there, same bee, because I marked her in case the bees swapped out queens or something, because there were other cells in there, swarm cells in there. But she was moving around yesterday quite a bit and fast, and I never saw her lay an egg, and I don't see any evidence of egg laying or larvae in that hive.
Mhm.
How long can she stay in there if she didn't successfully mate? And will the bees get rid of her? Will they do a supersedure? Or do I have to go buy a queen?
So this is your own queen that you produced?
Yeah, well,
Okay.
they produced her, but yes, she came from my hive.
Right. And so what's going on in your environment right now? Like, is there plenty of pollen in there? Are they building infrastructure? Are they investing in the hive?
They are building infrastructure, but slowly. I feel it's pretty slow. Like if I had drawn out frames, I would put them in there. But she had plenty of space. There's plenty of space for her to lay.
Mhm.
They have good honey. The frames that are full of bees have a really nice pattern on them, except for they don't have cap brood. So they have nectar, they have pollen, they have honey. But I don't see anything coming up.
Okay, so here's something I look for if I have a queen that is probably still going to produce, but just hasn't been triggered yet.
Okay.
If we look at the brood area where she would be laying her eggs, the standard center of the brood, if they are not starting to fill that area in with nectar and resources, in other words, ignoring the nursery and giving up on the fact that it would be a nursery, I would worry. If they're keeping that space open for her and they're storing their resources out around the perimeter and away from that brood area, then there's still hope that she's going to lay. This time of year, a lot of people jump the gun on their queens and they try to order new ones and they show up and they kill the queen and a lot of things go on there. But I think this time of year, now I'm not familiar with your climate and your local area, but those are the things I watch for. If I pull a frame and it's like, she has no room to lay. They start backfilling the brood area, then they've got a problem then. But if they're still holding space for her, it sounds like the pheromone is right that they still anticipate that she's going to lay eggs soon.
Oh, that's great news. I mean, just a couple weeks ago, I had 4 hives and only one queen, original queen, because I split and then I had 2 swarms. So I had 4 hives and only one queen. And now I have 4 hives and I have 4 queens.
There you
So
go.
I'm pretty happy. So I'm hoping that it works out that way as you spoke of.
So when it does work out, let me know, Gina. And if things go bad, we never met. So,
Yeah, okay.
okay. All right.
All right, looks like we got a question in the chat there. Says, have you finished up your dual queen keeper's hive? Plan on using the flow lift to get down into the exchange box. I don't know if you can see that question there.
Okay. Yeah, it popped up. I was trying to avoid it. So, so for those of you who don't know, the keeper's hive, well, they really want. I made a huge mistake by committing to the dual queen system, the dual colony system with the central riser. And yes, it's out there. It's not in the bee yard yet. It's not painted. We just get out of the snow here, by the way. But I almost don't want to deal with it. And here's why. The two queen systems, I guess they turn into lions or something. I don't know what happens. If you look at the inventor of the keeper's hive, George, and yes, he's curious about many things. They had to walk away from their dual queen system. Like they were opening it up to show how much honey they got, and the next scene they're 50 yards away trying to recover from all the stings they got. They brood up big. You get this massive honey, and so I thought, wow, wouldn't it be cool to just put a 7-frame flow super on there, which matches your 10-frame Langstroth, and to get all this honey. But the problem is apparently these double queen systems produce so much honey in such a short amount of time. I don't know if they would even have the time to finish drying it down and capping it before I would need to put even more supers. I think I overpromised on that system. I would like to fall back on just the single brood box keeper's hive system. Very promising as you know, as it functions, the way it's set up and everything. And of course your honey supers are 5-frame nukes, so lifting is not a problem for people. But the two queen system, just to answer the question, it's in my garage. It's not out there. It's not painted. It's not put together. I'm way behind the power curve. I'm probably going to get stung and run away and have to put it on a video. I don't know if it's going to work, but I'm going to do it just because I said I would. And I paid for that, by the way, with my own money. But the two queen systems, I don't know what your experiences are with those, everyone that's watching, but apparently they just turn into monsters. I don't know what happens. But rich person says, okay. So sorry about that. I'm gonna have to let people down on that one. But the two queen system, I want to go back to the one queen system.
So one more question. Do you prefer the single brood management or the double deep?
Keep in mind, I've always done the deep and the medium. Double deeps are kind of too big for what I do. And this year, I'm staying with the deep and medium setup for brood. And then everything above that, although here they tend to occupy just a single 10-frame deep. And they just arc up into that medium box. And I get established what I call the honey bridge, because once we're set up there, the queen doesn't lay beyond that once they've set up nothing but honey somewhere in that run. And so I don't use queen excluders. This year, I'm using queen excluders to push the queens down early. So we've got that medium and we've got the deep brood box. The medium box now is all brood because we're just coming out of winter. So I'm taking the queen out of there, putting the queen excluder in under the medium and putting the queen down in the deep box and letting her go. And then my thinking is, and I'm 99% sure it's going to work out, that the nurse bees will go and join the queen down there. And those that are up in the brood in that medium box now will emerge and come down and just join those in the bottom. So I would like to concentrate my bees more into the single deep brood box management system. And then once they're set up there, remove the queen excluder and then have them building honey there going up. But I have a good friend, Steve Rapaski here, who has a big commercial operation. He's gone to single brood management in my state, in my zone. and it works really well for him. And then, of course, he has to back feed those heavily in fall, which is something I like to have them build their own resources, and then I just leave those on. But single brood management can work here, even in the cold. And for my horizontal hives, we have the long Langstroth hive, which I like a lot. If you're getting older and you just want to lift light things, any of the horizontal hive formats are fantastic. There again, we would just leave 10 or 11 frames for brood. And if you wanted to control that, you would put a queen excluder in kind of like a follower board and then have nothing but honey after that. And people that do that are starting to win me over a little bit, because this expanding and contracting of the brood through winter and as it transits through, I used to think, well, yeah, well, we just pull these frames out over here, slide them all back. Now we got the brood at the entrance again. But then, of course, now we've got comb that has had brood in it that we now have honey in, and it's ugly. So for aesthetics, and if you want to harvest your honey and you want it to look good, you want to use cut comb and things like that, people are winning me over in kind of containing the queen and brood to the first 10 frames. So I'm starting to see the light on that, where before I just thought I was such a genius by letting them just use everything. But
It's
so
so cool.
queen
Thank you.
excluders, yeah, single brood can work. Yeah.
Thank you.
Yep. So all out, that's the end of all the questions.
Are there any other questions?
I have one,
Please, Gina.
if you don't mind. I think my bees are so slow to draw comb. And there are probably 3 or 4 frames in my 10 frame that are at least 4 that are not drawn at all. And then they'll have another that they're just starting to draw. I've got a lot of bees. I probably have 5 frames worth of bees. And shouldn't they be drawing comb at this time? And we have good food, good nectar. And so what is, or do I just have maybe not good hives?
Well, are you using standard 10 frame equipment?
Yes,
And is it your like number 1 and number 10 frames that don't get finished out?
always 1 in 10, but right now I have 1 and 9 and 10, or 8, 9 and 10. Yes.
Yeah. This is why one of the reasons
And
a
I
lot of
swapped them out too. Sorry to interrupt you. I did move them in between very
Mhm.
active frames, thinking maybe I can encourage them to draw that out. And it's,
okay. Well, this is one of the reasons, like, I hate to bring up Tom Seeley again, but he's an above average beekeeper. He keeps his bees now in the 8 frame equipment. And because for so many years, he's in Maine now, and they weren't ever fully utilizing the most distant frames.
Mhm.
Now, where I am, depending on how you set up your hives, like my preferred landing board exposure is south by southeast. And then we find that they build to the morning sun first, so the sunrise side. So, and then of course the sun setting side were the frames that were last to be finished out, if at all, because what they were doing is then moving up rather than even expanding out to those. So he went to all 8 frame equipment. I've got some 7 frame equipment where they use everything. They fill every frame. And then we just go up from there. This is also why I like those 5 frame nucleus hives. Easier to manage, easier to lift, and they go vertical and they use it all. And also much smaller colonies are much more productive in that small space. So that's really interesting too. I did some mean tests with them last year, and I only put double bubble on the top and a migratory cover and no feed. And I just thought they were doomed. And of course, I just wouldn't tell anybody that I was mean like that, if they didn't make it. But then they made it in spring, including that queen on a stick swarm. They made it. And I felt bad actually, because I wanted to feed them and I couldn't. We had this extended winter, and and we didn't know what to do. So I just had a little double bubble on top and a migratory cover and whatever resources they stored themselves. But what we're learning, or what I'm learning based on what I see here in my climate, is that these narrower, tall systems are much better utilized by the bees, and that all the frames are full. I would, of course, if I were in your situation with the equipment that you have, find the first from the edge, the first one that's fully drawn, and of course push them in. You did mention that you already have kind of checkerboarded a little. The other thing is, we know that in springtime, once they're bringing in resources, they'll ignore sugar syrup. I don't know how you feel about feeding your bees these light syrups, the 1-to-1 and the 1-to-1.5, have resulted in a lot more comb production. In other words, once they're doing that, to keep them doing it. The other thing is they need warmth to produce their comb. So think about 85 degrees away from the cluster. This is why further away, the less comb production there is. It's also why they like to build up, because it's warmer if you've trapped that warm air up above, and your comb builders have a more suitable climate to continue to draw the comb. So the surplus resource, the sugar syrup, the light stuff, and then bees that are already actively producing comb. Once I know they're producing comb, that's what I use them for. That's also what I use my resource hives, these nucleus hives. If I put a swarm in there, a swarm is a comb producing machine. They are ready to do it. So what I do is I keep them building it. So I keep fortifying them. Because if they pause, if they stop, it's like a work stoppage anywhere else. Getting the crew back, getting them on the job and productive again can be difficult. So once they're in that mode, kind of keep them in the mode, and smaller spaces tend to be something they utilize better where I am.
Great information. Thanks.
You're welcome.
Thanks, Fred. We have one more question in the chat, which is any concern if I place my water source on top of one of my hives?
Water on top of the hive. Okay, I personally just wouldn't do that. And the thinking is you might have to access that hive or pull the cover off. One of the things that we really want to do is have a consistent, predictable, dependable, clean water source for the bees. And I like to keep it in the apiary, by the way. So convenience is important. It's not the same as, putting sugar syrup out or open feeding, or, have a robbing station in your apiary. Those are bad. Water everywhere is kind of a good idea, but on top of the hive, personally, I wouldn't, just because it's in the way of the utility aspect of me getting into the hive when I want to. And how do you keep it full, and what kind of feeder is this? I've gone to a moss wall, which to me is really fun. Looks good. I feel good when I see it. Cinder blocks and stuff, some concrete work that's really loosely done. I tell people on purpose rather than say I'm not a skilled mason. And then I cover it with moss, and then I have a fog nozzle. If you've never seen a fog nozzle, you should really get one, because it atomizes the water so light that it keeps all these surfaces damp. The bees land on the moss and they drink, and they look better when they're on moss than when they're on anything else, including your pie plate full of marbles. That's not as cool as moss. And so I would just prefer you set up a nice half shade, half sun area where you have water for your bees. Okay, now some people said, I set up a water station and so far not seeing any bees accessing it. The good news there is, was that Gigi? Anyway, the good news there is they're getting water somewhere. Bees are going to go after water. So that's the good news. Now we have full with different water types. And by the way, their desire for water changes through the year, the different types of water. I've done salt studies, so including the Celtic sea salts and all the expensive stuff. And adding salinity to water draws them also at different times of the year. And putting pool tablets in barrels of water draws them to those instead of your neighbor's pool. So if you have these chlorinated water bees that just have to have chlorinated water, they'll go there, and it has to be consistent. Once they go to the pool and discover a resource there, that's it. You're going to be on bad terms with those neighbors. I've never been on bad terms with neighbors before, but I've heard about it. And so setting up water stations for your bees early in the year and continuing to keep those as stable. And like if you put out salted water, it's 1 teaspoon per salt per quart. And always have fresh water options also. In other words, don't just put out salt water. Don't just put out mineral water or spirulina. Spirulina in water has not been great. Spirulina and sugar syrup, they go for it big. So for those that feed, and go to Google Scholar and look up the studies on spirulina. It's not just for people. That stuff is amazing. But water sources on top of the hive. Also, some people write me and they set up water inside the hive in a rapid round or something. Please don't do that. So they want to control their own humidity and inside the hive, and it's best to let them do that.
Well, thank you very much, Fred, for the presentation and for answering so many questions. We're thrilled to have you here with us today.
Sure, thank you. Thanks for having me back, and sorry about last time.
Yeah, it's our pleasure to have you. One quick announcement for folks on our calendar. It's there in May. We're going to have Dr. Juliana Rangel from Texas A&M come and speak with us on May 22nd at 7 p.m. via Zoom. So that's going to be our May speaker series. Once again, Fred, I thank you very much. Also, there's a 3-hour time difference, so Fred very graciously is staying up late for us. So we appreciate that. Thank you once again, Fred.
Thank you so much. It was a pleasure to be here. Appreciate it.